How does observation affect quantum reality? Have you ever wondered how simply looking at something can change what it is? In the world of quantum mechanics, this idea is not just a thought experiment. It is a fundamental truth. The question we are tackling today is how observation affects quantum reality. At the core of this concept is the observer effect, which reveals that the act of observing a quantum system alters its behavior. In everyday life, we expect objects to have fixed properties. However, particles like electrons or photons exist in a state of uncertainty until they are measured. This uncertainty is described by something called a wave function, which represents all the possible states a particle can be in. When an observation is made, this wave function collapses, and the particle takes on a definite state. One of the most famous demonstrations of this phenomenon is the double-slit experiment. When electrons travel through two slits without any observation, they behave like waves. This creates an interference pattern on a screen behind the slits, suggesting that each electron goes through both slits simultaneously. However, when a detector is used to observe which slit the electron passes through, the interference pattern disappears. Instead, the electrons behave like particles, going through only one slit. This shift shows that measurement changes the outcome, collapsing the wave-like behavior into a particle-like state. It is important to note that this effect is not about a conscious observer magically changing reality. Instead, it is about how the measurement process interacts with the quantum system. For example, detecting an electron usually involves bouncing photons off it, which disturbs its state and changes its behavior. Thus, in quantum mechanics, observation means any interaction that gathers information from the system, not just human observation. Scientists have created tiny devices to test this phenomenon further. They found that increasing the sensitivity of a detector can change the interference pattern more dramatically. When the detector's sensitivity is reduced, the wave-like interference pattern returns. This indicates that the observer in quantum physics can be a simple measuring device, not necessarily a conscious being. From a quirky science perspective, this phenomenon challenges our traditional views of reality. It suggests that at the quantum level, reality is not fixed until it is observed or measured. Some interpretations even propose that consciousness or observation plays a fundamental role in shaping physical reality. However, this idea remains controversial and is not widely accepted in mainstream physics. In practical applications, the observer effect is essential for technologies like quantum computing and quantum cryptography. Understanding how measurement affects quantum states is vital for these fields. This concept also opens up fascinating possibilities about the nature of reality, blurring the lines between the observer and the observed in ways that seem almost magical. Ultimately, observation in quantum mechanics changes what is observed by collapsing possibilities into a single outcome. This makes quantum reality a strange and dynamic interplay between measurement and existence.